Welcome to EDUSYL. In this video we are going to focus on the VoIP packet transmission in wireless medium. Basically the previous video we have already focused where the VoIP packet transmission was done using the wired medium, which was just a basic program we have done. With the previous codes we have seen there are two hosts. Those who have not checked the previous videos, please check that one in a playlist. And also I have kept in a description of this video. Please check that one before checking before viewing or before watching this video. So here our target is a wireless environment we have to create where certain devices we keep. Within the certain devices we have just written the code. These sessions basically the codes which we have written that we will describe, and if time permits we will be focusing on a new session where the scratch codes we are going to write and every details we are going to keep. Let us start. So I kept here a .NET file, Wi-Fi.NET file, where I kept in a design portion I kept host 1 2 host 3 4 host 5 6. Basically I tried to communicate between these 6 devices with the communication is being established using a full duplex mode. So here aggregation showcase I kept where it is the network name. You can change it also, and INI also we discussed in a previous videos where it's a executable file where we have to write what a host like host 1 host 2 everything we have to first readily available this name or terms. Here host 1 which we discussed before, host 1 is we named this as host 1, and ad hoc means definitely they run in a wireless environment, and this is possible due to INET package. I'll tell you that one in the upcoming videos where we will be focusing on the scratch videos, scratch writings, everything we will be discussing in that session. So here these are the focusing terms that which we have already written. Next is that INI, which is the main focus we should keep. We have to first limit the time, how much time that we need to run this uh, simulation, that we have to first write it as 10 second. You can write 1000 second, 100 second, it also up to you. Next is traffic between S1 to S2, which we uh, first write that applications, how many number of applications that you want to run in a background, that we first have to write this one. And type name is your what type of application that you want to run in that host. Basically it's a UDP basic app, means just an app. UDP TCP that you have read, UDP is basically used for connectionless protocols. It's a connectionless protocol, so basically a voice, a real-time voice, you can say real-time video could be useful for this. So it's a basic app, just a basic app where we try to run this UDP basic app. And the destination address is host 2. Here host 1 2 I have written it clearly, traffic H1 H2, where the name we kept is UDP basic 1, and then host 2. Then I kept a destination address or the port address. Basically the port address we have to keep uh, at least to communicate, because it's a peer-to-peer communication. So host, the port address should be similar. If you want to communicate with H1 to H2 means host 1 to host 2, both of them the port should be common between them. And the length I fixed is 100 bytes. Basically 100 bytes we kept to send data. Okay, now next is like this host 3 to host 4, also I kept a communication between them. I kept same port ID for both the devices. You can change it if you want to change, you can change, not an issue. But the port IDs, if you are changing here, here also you need to change. And similarly for 5 h5 and h6 means host 5 and host 6 that I kept, I've changed like here you can see the application 1 I kept, like here two different applications are being run inside h5 to h6 means it's a duplex communication. You can see number of application it will run is 2. Why? Because one is here as the h5 is acting as a sender part. Why? Because here you can check destination address, it is written as host 6. Now here also the one I kept as application, the second application basically for host 6. Here the destination address I kept as host 5 means for 1. Here you can check the application 1, this code is the sender for host 1, and here the application 1 is a receiver for h5 host 5. So UDP sync just an application where we can expect, or the basic app will be from the sender side and sync from the receiver side we kept. So you can check everything, like every details. It's a number of application that we have already said is 2 means there will be a chance between two different devices will communicate as a full duplex communication will be established. And next portion I have written as G, that I have already told you that IEEE 802.11g that I kept, where the maximum speed or the maximum bit rate we can expect is 54 Mbps as per the research paper that we have already gone through. Next classifier, like here the classifier what QoS classifier that we have kept, like here the type name we have to run an application. Here we have to focus on a classifier that should be QoS should be maintained properly. Next it should be is a QoS station will be true. Next we are just running a global ARP, address resolution protocol. Next the IPs, these are the functions we are focusing on, those IPv4, that's why we need to write it properly. Next here three concepts we are focusing on, either no aggregation. If you want to aggregate means the packets you are going to aggregate between like 3 packets or 4 packets or whatever you are going to get. You have to first keep the maximum AMPDU size, either AMSDU or AMPDU. There are two different kinds of aggregations that we have already gone through. Next, config as a priority aggregation. Based on the priority aggregation, like the aggregation when we are doing, it should be the port address we have changed as 5000. So these are the time it takes while we are trying to send the interval. So there should be any interval between the packets it getting generated. Now we will run it. Once we will run, then we will just focusing on, like these are just a basic application, and next video we are focusing on the VoIP communication within Wi-Fi access point. Now we will run it and we will get the correct idea about it. So here it is running. Now a pop-up came whether we can go for the no aggregation, aggregation and voice priority aggregation. First we start from the no aggregation. You can press OK. Here this window will exactly say like in progress friends, how many packets are there, though we started with this. So it just asked us such information which we have already set. Now if you want to run, as we have already discussed, if you want to send a voice, it is taking the by default is 20 millisecond, but here we are not going to use those voice, we just send a simple UDP one, so that's why it is not taking 20 millisecond. So first of all will send the request to all, like there are the host as 6 hosts are there, so they are sending the informations to all the host. Now acknowledgement, because we have already said host 1 and host 2 they will be communicating once it is sending the data, like it's data 1 now it is sending. So here also host 6 it has sent the information. Now from host 5 we can expect the acknowledgement. Here also the host 1 and host 2 both are now communicating, so that's why the acknowledgement was somewhere we are getting acknowledgement. Now data 1 data 0, now it's because we have already said the both the end, host 5 could be a sender, host 6 could be a receiver, that we have already discussed before. So and host 1 host 2, host 1 will be the sender and host 2 will be the receiver. Here also the same for host 3. Host 3 will be the sender and host 4 will be the receiver. But for in this case, host 5 and host 6, both the end anyone can send and anyone can receive. Now it has sent means it this host 6 will definitely acknowledge. Yeah, now acknowledgement got. Now it says to any of this. Now host 3 started its first data, so that's why it is written basic data 0, and from this connections it where you are sending, so that particular machine will send you the acknowledgement. So in this way we found that host 6 means 6 already built. Now seventh one is running. So in progress, how many packets are there? It has written as 2 packets. So in this way we have completed somehow which exactly we have written the code for it, and we have just discussed this one. Now we will focusing on the result part. To find the result part, you have to just close this one, and we will go to the ANF file which has been generated. Here no aggregation, that we have run the no aggregation, that's why we got it. And browse data, it is written. So here for aggregation, if you want to find a drop, you can write drop. If any drop count is being found, like here the count drop is there, so it will show you what exactly that they have found. Suppose I have selected this one by pressing control, so here this one, and suppose you want to put a bar graph, you can line chart also could be possible, not an issue. I just clicked on a line chart to verify whether informations are correct or not. In this way you can create your own graph by just checking the back of everything, those we have which we have already selected. So in this way we have completed the simple one, which is a part one of this video. Second part we will be discussing about the VoIP transmission between the devices which we have already kept. So till then, thank you all of you. Have a good day.